You know that feeling, right? That sinking in your stomach when your beautiful code just crashes. If you've been there, you are in exactly the right place. Today, we're going to turn that frustration into a superpower. Seriously, by the end of this, you're not just going to know why your code breaks, you'll know how to control it, how to build applications that are tough, reliable, and just better. Let's get into it.
We have all asked this question. You spend hours writing what feels like the perfect script, you hit run and poof, it's gone. Or maybe worse, it runs for a little bit and then suddenly dies, throwing up a whole screen of angry red text. It is the universal developer frustration. But what if I told you that crash wasn't just preventable? What if you could actually be in complete control of it?
So here's our game plan. First, we're going to stare that crash right in the face and understand what it really is. Then we'll build our very first safety net. From there, we'll keep upgrading our tools, learning how to handle any failure with total precision. We'll even learn how to create our own rules for our code. And then, for the grand finale, we'll put it all together and build a real application that just refuses to die. Sound good? Let's go.
Okay, first things first, we gotta understand our enemy. What is this thing that just stops our programs cold?
In the world of Python, this enemy has a name. It's called an exception. Now, this isn't like a typo that your editor highlights for you before you even run the code. Oh no, an exception is a surprise problem. It's an error that only shows up while your program is live and running. It's like an uninvited guest crashing your party.
I absolutely love this quote from the source material. It's this great mix of Urdu and English that just says it perfectly. An exception is an error that happens at runtime. It's so simple and so true, right? I mean, think about it. If your code asks a user to type in a number and they type hello, well, your code can't know that's a problem until it's actually running and trying to process that input. That is a runtime error.
And here it is, live in action. Look at this code snippet. We're trying to do num equals int open paren hello. We're literally asking Python, hey, can you please turn the word hello into a number? And Python quite reasonably says, no way. The moment it tries, it throws what's called a value error, and the entire program comes to a screeching halt. That right there is the crash we're here to fix. Okay, so how do we stop the crash? How do we prevent that halt? Well, we need a safety net. And in Python, our first and honestly most important safety net is something called the try except block. Just look at the difference here. It is night and day. On the left, you've got the dangerous code. If a user types hello, that program is dead. But on the right, we've wrapped that exact same risky line inside a try block. Now, when that error happens, does the program crash? Nope, it just gracefully jumps down to the accept block, prints our message invalid, and then just keeps on going. It's such a small change, but the impact is massive. Here's a really great way to think about this. The try block, that's your daredevil code. That's the risky stuff that might just fail spectacularly. And the accept block, that's the safety net you've set up right underneath it. So if the daredevil falls, the net catches them, the audience cheers, and the show goes on. No crash. Now that big general-purpose safety net is a fantastic start, but if you want to write truly professional-grade code, we need to get more precise. We don't just want to know that something went wrong, we want to know exactly what went wrong so we can handle it properly. Time to level up. So why get so specific? Well, first, you can give your users way better feedback. Instead of just a generic oops error, you can say, hey, you can't divide by 0, or whoa, that's not a number. This also lets you take totally different actions for different problems. And let's be honest, it just makes your code look and feel so much cleaner and more professional. Check out this example. We're asking the user for a number and trying to divide 10 by it. Now, this one line of code can actually fail in two completely different ways. If the user types hello, the int part fails. That's a value error, so our second except block catches it. But if they type 0, the int part works, but the division fails. That's a 0 division error, and our first except block catches that one. See? Precision.
Okay, so we can catch errors, and we can catch specific errors, but the try except structure actually has two more secret weapons. They're optional, but they are super powerful. Let's complete our toolkit with the else and finally blocks.
This slide maps out the whole mission. Think of it like this. Try is your main plan. It's what you hope will happen. Except is your backup plan. It only kicks in if the main plan goes wrong. Else, that's your success plan. It's what you do only if the main plan worked perfectly. And finally, that's the cleanup crew. They show up at the end guaranteed no matter what happened. Success, failure, doesn't matter.
Let's look at that else block. In this code, we ask for a number inside the try block. If the user types a valid number and everything works, the accept block gets completely skipped, and we jump right down to the else block to print their number. This is the happy path. It's a really clean way to separate the code that should only run on success.
And then we have finally. This block is a promise. It's a guarantee. In this example, we're trying to open a file. Now, whether that works or whether it fails because the file doesn't exist, it doesn't matter. The finally block is guaranteed to run. Process finished will always print. This is absolutely critical for cleanup tasks, like making sure you always close a file or a network connection.
So far, we've been playing defense. We've been reacting to errors that Python throws at us. But now, we're going to flip the script. It's time to go on the offense. It's time to create our own errors using the raise keyword.
Now, that might sound totally weird. Why on earth would you ever want to create an error? Well, you do it to enforce the rules of your application. Think about it. What if a user enters an age like -5? Python sees that as a perfectly valid number, so it won't throw an error. But in the logic of your app, that's impossible. You need an error to happen there.
And this is exactly how you do it. We get the user's age, then we check it. If that age is less than 18, we use the raise keyword to manually trigger an exception. This immediately stops the program right there with our own custom error message. It prevents that access granted line from ever printing for someone who's underage. You are now laying down the law in your own code.
All right, theory time is over. Let's put everything we've learned together. We're going to build a simple but really tough login system that uses every single tool in our toolkit to handle whatever a user throws at it.
Okay, let's walk through this masterpiece. Inside our try block, we get the username and password. Then we have our own rules. If the user isn't admin, we raise a value error. If the password isn't 1234, we raise a value error. If either of those things happens, the code immediately jumps down to our accept block, which prints login failed and our helpful message. But if they get both right, we skip accept and go straight to the else block for a login successful message. And no matter what, success or failure, that finally block runs at the very end to say thank you. See how it all fits? It's beautiful.
So let's be crystal clear. This whole exception handling thing, it's not just some fancy add-on. It is the absolute foundation of building professional, user-friendly software. It gives you stability, so your app doesn't fall over when someone types the wrong thing. It creates safety by letting you manage problems without panicking. And most importantly, it creates a way better user experience because you're replacing an ugly, scary crash with a clear, helpful message.
You now have the entire toolkit. You have everything you need to build code that doesn't just crash. You've gone from being a victim of errors to being an architect of resilient, robust applications. So I have one last question for you. Think about a project you're working on. What's the very first error you're going to go and catch with your new superpower? Thanks for joining me.